Okay, so let's continue the discussion on the handout. So we are on the empty set. Okay, so what is the empty set, right? Or sometimes it's called the null set, right? Same thing, empty or null. And on your handout, right, the empty set, also called the null set, obviously, is the set that contains no elements. So it's the set, okay, here's the set braces, that contains no elements, right? There are no elements in here, right? That's why we call it the empty set, because it's a set with no, that's empty, literally empty. And another way of denoting this is a 0 with a slash. Again, that doesn't represent, this is not the number 0. That means this is a set, excuse me, a set that's empty. Or we have the braces here. And then the following the empty set, on your handout you see the set of natural numbers. And we usually denote it with this big N, right? That means, well, the short way, the set of natural numbers. Okay, so there's a lot of numbers that we work with in math. One of them is called the natural numbers, which literally comes naturally to us. If I ask you to count to 10, you would say 1, 2, 3, 4, 5, 6, dot, 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 right? That would come to you naturally. Or sometimes we call these numbers counting numbers, because that's how we learn to count, right? 1, 2, 3, 4, and so forth. If you ask, a kid to count up to 10, they're not going to say 0, 1, 2, 3. They'll start out 1, 1, 2, 3, 4, and so forth. So this is the empty set, and this is the set of natural numbers. And let's see, how are we doing? So it's 2 minutes. So let's do a quick example of the empty set. Where are we actually going to use this? And you'll be using this a lot in your statistics class. You take stats or math and society. So let's see, let's say example 1. So here's my set, and I'm going to say X, this is in set builder notation, X such that X is a square with exactly 3 sides. So, this big X could probably represent, all polygons, right? Poly meaning many, gons meaning sides. So, all the shapes that we have, such that, right? Such that what? Something specific happens, right? There's a specific restriction, right? Or condition. And again, so this is, we know, set builder notation. And well, this would be roster method if we wanted to actually list. But how many, let me do this in color. So how many squares do you know that have exactly 3 sides? Well, all the squares that I have learned have 4 sides, right? Every single square that we know has 4 sides. So, I mean, this set is empty. There are no squares with 3 sides. So this, right, is literally the answer. Or if you want to say the empty set. Okay, so that's an example of the empty set. Let's move this up and let's quickly do example. Well, I guess we'll call it example 2. So the set of natural numbers. Let's practice with the set of natural numbers. Let's see, what is a good problem? How about the set, let's see, so X, and is a natural number, and I'll explain this notation in a bit, this E. such that x is greater than 4, and that same x is less than 1. Okay, this guy means belongs. Okay, this E means belongs, right? Or it means is an element, right, of the set, or is a, member of the set. So quickly, let's see, in our example, right, okay, so you are a student, so let's just say Tyler. So Tyler is an element, right? He is a member of set A, which I happen to call the set of everybody who's enrolled in my class, right? So that just means you belong in that class, in that set. I mean, if you want to draw a picture, right, that could be like your set A, right? And then there's Tyler in the class, right? And then there's the other 16 students. Okay, x is a natural number. This is set builder notation. So first, this is the general one, the general kind of statement. And x is a natural number. Okay, so now I know I'm going to start with 1, 2, 3, 4, right? And you can keep going. But they say specifically, x is a natural number such that x is greater than 4. Okay, well, if it's greater than 4, then these guys are not here, because if it's strictly greater than 4, then it's got to be 5, 6, 7, 8, right? And you keep going. Okay, so check. And that same number is less than 1. Well, I have 5, 6, 7, 8. Which of these guys is less than 1? And the answer is none of them, right? 5 is greater than 1. 6 is greater than 1. 7 is greater than 1, not less than 1. So there are no natural numbers such that x is greater than 4 and x is less than 1. So this set, right, we were trying to do the roster method here, but we couldn't. Right? This set is literally empty, or we say the empty set. Okay, so I'll stop here and I'll do the video that comes right after, which will talk about cardinality.